Good day. My name is Tumelo Munzhelele. I'll be giving a presentation on Pareto optimality and general equilibrium analyses. This is submitted as part of my History of Economic Thought course at the University of Witwatersrand. This presentation is divided into three parts. The first part will look into the economists that were involved in the development of Pareto optimality and general equilibrium analysis. The second part will look into the development of Pareto optimality and general equilibrium. I am going to use an example to go through this part because the two models are quite technical, and I think an example is the best way to try and explain the models. And the last part will look into walrus theorems and its implication in economics in general. The first economist that we're going to discuss, who was important in the development of Pareto optimality and general equilibrium, is Leon Walras. Leon was born in 1834 and passed away in 1910. He was a French national, and in modern day language, he would be referred to as a mathematical economist. His work history is actually quite interesting. He started off by studying engineering. He did not complete the degree. Historians believe that it was his lack of understanding of mathematics actually that stopped him from being able to complete his degree in engineering. But nonetheless, he went on to do a variety of other jobs before he became an economist. He started off as a bank teller, then a journalist, a romantic novelist, and the one that he's most famous for was a railway clerk. That is right before he went into economics. Even though his understanding of mathematics might have seemed to have stopped him from completing his engineering degree, that did not stop him from being one of the pioneers of an era in economics referred to as the marginalist revolution, which is actually best known for its use of mathematics in economics in order to develop or also explain economic theories. His contribution to economists, he developed the marginal theory of value, and this was independent of William Chavez and Carl Menger, who also developed marginal theory of value. The second economics that we're going to look into that contributed to the development of Pareto optimality and general equilibrium analysis is Vilfredo Pareto, of Pareto optimality, of course. Pareto was born in 1848 and passed away in 1923. He was an Italian national. He was an engineer, an economist, and a sociologist. Historians record that Pareto seems to have turned to sociology for an understanding of why his abstract mathematical economic theories did not work out in practice. And he seems to have concluded that much of social action is non-logical, and that action that individuals tend to take sometimes are designed to give spurious results. So he believed that the gap between his models predicting real life behavior is that human beings were not always rational. So his contribution to economics was the development of Pareto efficiency and then also Pareto optimality. And perhaps what is more important is actually his contribution to modern day microeconomics with his concept of income distribution. And actually, the relationship between Pareto and Walras is that Walras used to be the chair of the School of Economics at University of Lausanne, and when he retired, he actually recommended that Pareto succeed him, and Pareto did go on to succeed Walras. All right. The third economist that we're going to look into is Francis Edgeworth. Edgeworth was born in 1845 and passed away in 1923. He was an Irish national. He was a philosopher and could have been at that time referred to as a political economist. Modern day, we probably would just refer to him as a statistician. His contribution to economists is he contributed to neoclassical economics through the development of the utility theory, which is quite fundamental to microeconomics to this day. And he introduced the indifference curves, which are also very fundamental to microeconomics. And of course, if you've done either mathematics or statistics or economics, you would have been introduced to the Edgeworth boxes. He obviously contributed to that, and they are named after him. All right, so let's get into the background terminologies that will be used in the models of Pareto optimality and general equilibrium. So we're going to look into an exchange economy. So people trade their own good, but no production takes place. So that it's an assumption, it's a simplifying assumption in the model. An endowment is basically a bundle of goods that an individual starts out with before trading. The Edgeworth box, as we've already discussed, Edgeworth himself, it's basically a tool that is used to depict the quantities that are available in the economy and how each individual will likely to trade with the initial quantities that they have. Pareto efficiency occurs when it is impossible to make one party better off without making someone worse off. It is important to remember this concept because it is quite central to the conclusions in the theory. And then Pareto improvement occurs when at least one individual becomes better off without making the other individual worse off. That would be Pareto improvement. All right. Like I said, I am going to use an example to explain how general equilibrium works, and also within that, we will get to the idea of Pareto efficiency and Pareto optimality. So as an introduction to the example, please note that we have two consumers in this economy. Their names are Jerry and Elaine. They have endowments of boxes of cereal and pancakes. So they're basically going to trade breakfast meals. Their allocation of goods are denoted as follows, and this is important to just sort of make note of the notation that is used in the model there. So the allocation of goods that Jerry has is shown with superscript J for Jerry, and the subscripts are basically to show whether a C for cereal and then P for pancakes. Okay, and then in the economy, the total quantities that are available in the economy, so the total endowment in the economy, which would actually become the limits to the Edgeworth boxes, are determined by adding. So in terms of cereal, we'll add the total cereal that Jerry has plus the total cereal that Elaine has will make the total cereal that is available in the economy. And in terms of pancakes, the total pancakes that Jerry has plus the pancakes that Elaine have will make up the total pancakes that are available in the economy. And as I've already alluded to, those two totals become the limits to the Edgeworth box in this particular example. All right, so in this example, we then determine that Jerry has 6 boxes of cereal and he has 4 pancakes, and that Elaine has 4 boxes of cereal and 4 pancakes. That would mean that in this economy, we have 10 boxes of cereal and we have 8 pancakes. That is a sum of both of their endowments. All right, so for those who might haven't seen the Edgeworth box, this is how it looks like. Let me just grab a highlighter here. All right, so as discussed before, the limits to the Edgeworth box, so from there up to there, and also from here up to there are determined by the total sums of endowments that are available in the economy. Right, so let's just look into how the Edgeworth box is constructed. So it's constructed by basically merging two XY axes together into a box. So Elaine is on the X axis and the endowment of Cyril is shown. As shown before, the total amount of cereal available in this economy was 10. And Elaine's pancake possible endowments are also on the y-axis, and as shown before, the total amount of pancakes in this economy is 8. The same thing happens for Jerry. Jerry's x-axis shows the total amount, that would be Jerry's x-axis, shows the total amount of cereal that is available in this economy. And also it shows on the y-axis, you see Jerry's total amount of possible consumption of goods available in this economy, which is pancakes in this example on there. So you'll see that the limits to the Edgeworth box, as we've discussed before, is the total endowment available in this economy. Right, so just as a matter of example, then let's look into point A. How do we read point A? Point A reads as follows. So Elaine has 3 pancakes, three cereals at point A and 6 pancakes, whereas Jerry has 7 cereals at point A and 2 pancakes. And at point B, just as another example to look into, Jerry has 6 bowls of cereal, and he has 2 pancakes. And at the same point, Elaine would have 4 cereal boxes and have 6 pancakes. And last but not least, if you look into point C, Jerry has 3 pancakes and he has 6 bowls of cereal, whereas Elaine has 4 bowls of cereal and 5 pancakes. That is how you would read points inside the Edgeworth box. All right, so what are we trying to do here? So we want to determine the Pareto efficient ways that these two goods can be split between Jerry and Elaine in this economy. That's essentially what we want to do. So which one of those many points within the Edgeworth box represent the Pareto optimal point? And to do this, we use the Edgeworth diagrams, of course, to depict the possible allocation of cereal and pancakes, as we've already seen in the previous slide. And this diagram is, of course, attributed to Edgeworth and Ball himself. All right, in this slide, we introduce the idea of trade and indifference curves. So indifference curves will then go into the Edgeworth box, where they would be used to help us determine the Pareto optimal point in the graphs. As human beings in general, we derive satisfaction from consuming different goods and services. And this satisfaction is referred to as utility in economics. So in this economy in general, Jerry and Elaine gain utility from consuming pancakes and cereal. Then we come to the idea of preferences. So preferences means that we will gain different amount of satisfaction when we consume different combination of the goods and services that are available in the economy. So if we in this economy, for example, if Jerry prefers more pancakes to cereal, he would gain more utility if he consumes more pancakes than cereal. And because of that characteristic of gaining different amount of utility when you consume different combination of goods, we then have the ability that human beings can rank the satisfaction levels that we get from different combination of goods and services. And the graphical representation of this ranking in economics is done using the indifference curves. So that's what indifference curves are there to do. They're giving a satisfaction that we derive from different combination of goods and services. So in this economy, we're going to allow Elaine and Jerry to trade, quite like it happens in a real economy. And that trade, because human beings trade based on their preferences, and Jerry and Elaine will be doing the same. This will result in utility maximization. So every human being will be trying to maximize their utility, and therefore they'll be trading with that in mind. And when that happens, we therefore have an improved welfare in the economy, wherein if you just had you gave if Jerry had remained with 10 of his pancakes maybe and 7 of cereal, but he preferred more cereal, in order for him to maximize his utility, he would be able to sell some of his pancakes to Elaine and get more cereal, and that would increase his satisfaction. And because Elaine has the right to trade, to decline or to accept the offer, it can only the economy can only result in Pareto improving allocation points. So at a point at which Elaine or Jerry decides that the trade of additional pancakes for less cereal or the other way around no longer satisfies their no longer increases their utility, they would decline. And that would mean the only possible options actually within the Edgeworth box are Pareto improving allocation. All right, so this is the addition of indifference curves into the Edgeworth boxes. As you can see on the graphs, indifference curves move away from the respective origin, and they represent greater levels of utility. So from Elaine's point of view, her origin is over here. And the further away you move from the origin, she gets higher utility. Jerry's origin is there, and the further away he moves from the origin, he gets higher utility. So Elaine prefers this indifference curve to that indifference curve, and Jerry prefers this indifference curve to that indifference curve. So in order to maximize utility, each consumer prefers more to less, and therefore all of Elaine's preferred indifference curve would be towards the right, whereas Jerry's would be towards the left. All right, so this is how the introduction of indifference curves look like in an Edgeworth box, as we've discussed. So the main question that we now want to answer is which Pareto improving allocation will be the outcome of this trade. So Pareto improving allocation is an allocation of endowment that improves the welfare of a consumer without reducing the welfare of the other. So in this diagram here, we have a point within or points within the diagram that is called the core. So the core is a set of Pareto optimal allocation that are welfare improving for both consumers. And if we conclude that a rational trade will only achieve allocations that are within the core. All right, so let's look into points A and C just to see how we end up with achieving points within the core. So if you look into point A, if you look into point A, it's inefficient because at any point in the shaded area, which is the core, including point C, you will yield both Jerry and Elaine higher utilities. So essentially, if you are at A, Elaine would prefer point C here because it would be a higher indifference curve for her. And also if you're in point A, Jerry here would prefer point C because he can be able to move there, which is a higher indifference curve for Jerry. So point A is inefficient and wouldn't make rational sense. All right, so how then do we know which points within the core will a consumer choose within the Edgeworth box? And that's when we introduce the concept of marginal utility. Marginal utility is the added satisfaction that a consumer gets from having one more unit of a good or a service, right? So then we go back into looking into point A again, and you can see that at point A, Jerry's marginal utility for Cyril was less than Elaine's marginal utility for Cyril. So at that point, Jerry was willing to trade Cyril for pancakes. And also, if you look at the same point again, the marginal utility of pancakes for Jerry's was greater than Elaine's marginal utility for pancakes. And essentially at that point, Jerry was willing to trade some pancakes for cereal for pancakes, and Elaine was willing to trade pancakes for cereal. All right, so the marginal rate of substitution is another concept linked to marginal utility, and is the rate at which a consumer can give up some amount of one good in exchange for another good while maintaining the same level of satisfaction. So while staying on the same indifference curve. So that brings us to the necessary condition that you need to have, that the two consumers need to have in order to maximize their utility within this economy. So that condition, the necessary conditions, that the marginal rate of substitution of cereal and pancakes for Jerry needs to be equal to the marginal rate of substitution of cereal and pancakes for Elaine, and it will be at that point that both consumers would be maximizing their utility. So graphically, this means that the efficient allocation occurs at a point of tangency between their two indifference curves. So following our example, Pareto efficient allocation of pancakes and bowls of cereal occurs at a tangency between Jerry's and Elaine's indifference curve. So you'll see the points of tangency in this curve is shown at point A and also at point C and also at point D, and obviously as we've seen before, D would be preferred as it is within the core, and that is the Pareto efficient point of allocation when the marginal rate of substitution for pancakes and cereal of Jerry is equal to the marginal rate of substitution for cereal for Elaine as well. So those core points that we discussed, we only looked into a specific portion of the core within the Hedgeworth box, but those points, the tangency points, actually exist in multiple places within the Edgeworth box. And to best show this, this key condition of exchange efficiency is that it happens when indifference curves are tangent to each other. That does mean we have a set of efficient allocation within the Edgeworth box, and when we connect those sets of allocation, so if we connect that point there and that point there, which are all efficient allocation, we get this line here, which is called the contract curve. So just as we've seen so far, how to get to Pareto efficient allocation. So just as a summary, when we're at a Pareto efficient allocation point, there is no way of making one consumer better off without making the other one worse. and all gains from trade are exhausted at that point, and there are no more mutually advantageous trades to be made. So that is the discussion on Pareto efficiency and optimality. In order to get to general equilibrium, though, we need to introduce pricing into that model. So the idea of pricing is introduced through the budget line, which is a graphical representation of all possible combination of two goods which can be purchased given the income and prices, such that the cost of each of this combination is equal to the money income of the consumer. So essentially what that statement is saying is that the budget line is showing us if you take the price of good X and the quantity of X that a consumer would prefer, and you add it to the price of Y, multiplied by the quantity of Y that the consumer would prefer, that would total up to the income that the consumer gets. So already you can see the assumption there is that the consumer uh, um, finishes their entire income on these two goods in the economy. So and then the next necessary condition that we then introduce into the models, that consumer equilibrium occurs when the marginal rate of substitution between the two goods is equal to the price ratio. That is the price of good X over the price of good Y. In our case, it was the price of cereal over the price of pancake. So when this condition holds, we will be at equilibrium, and will also be we've learned earlier, that would also be the Pareto optimal point, because this first part here represent Pareto optimality. So a market with exchange efficiency will result in the goods price ratio equaling the consumer's marginal rate of good substitution. So just to introduce add back the indifference curve into the model. So that is the budget line that we've just seen now, and those are the indifference curve. And the necessary condition that we're going to have for equilibrium is represented by that dot over there. So where the MRS of the goods A to B is equal to the budget line of the price ratio for the consumer. And this would be representing Elaine. So we just have the one part of the Edgeworth box representing Elaine. That would be Elaine's budget line, and that would be Elaine's indifference curve in this case. And the condition that we're going to fulfill is that the prices, as you multiply the prices with the endowment of each and every good that is in this economy, which is just 2, you would get the budget line. Similar process for Jerry as well. That is Jerry's budget line, and these are Jerry's indifference curve, and the necessary condition happens at that point where the MRS is equals to the price. And how these look like once we put them back into the Edgeworth box again is that this would be the budget line here. And this would be Jerry's indifference curve, and the blue ones would be Elaine's indifference curve. And that point there is the point that we just discussed, which is the necessary condition wherein the price ratio of the two goods in the economy is equals to the marginal rates of substitution for each of these consumers. That is the condition required to get to general equilibrium. So what is general equilibrium? Essentially, general equilibrium occurs when prices P1 and P2 cause both markets for commodity 1 and 2 to clear. That's essentially the idea of general equilibrium, is equilibrium in multiple markets. So the equilibrium in the cereal market then equals the equilibrium in the pancakes market, or causes equilibrium in the pancakes market. So, general equilibrium theory attempts to explain the behavior of supply, demand, and prices in a whole economy with several or many interacting markets. By seeking to prove the interaction of demand and supply will result in an overall general equilibrium. And we have just seen now, using just the two goods and the two consumers, we were able to get equilibrium in both the cereal market and the pancakes market. That's essentially what general equilibrium theory is trying to do. And obviously the demand was represented by the demand with Jerry and Elaine for cereal and pancakes, and we did introduce the prices of cereal and pancakes, and we did constrain it with the income that Jerry and Elaine would receive. So the prices of P1 and P2, so basically the prices of whatever goods are available in the market causes the markets to clear, and at that point we are at general equilibrium. And how it all links together with Pareto optimality is that trading in competitive markets achieves a particular Pareto optimal allocation of the endowments. And this is how we then get to the first fundamental theorem of Walras in economics. It's the theorem of welfare. So Walras' theorem it basically attempts to answer the question that we began with. We began with, is there an allocation of goods that satisfies both consumers in the economy? And using the Pareto efficiency condition, we were able to arrive, and preferences and prices, we were able to conclude that general equilibrium in a perfectly competitive market allows for the allocation of resources to be Pareto efficient. So Walras then went on to state quite an obvious conclusion at this point, but it actually wasn't at his time when the theory was developed, and is that if each individual satisfies his budget constraint, the value of excess demand is zero, and the sum of excess demand is zero, i.e. each consumer has maximized their utility. So essentially, Walras is then saying that in the economy, as trade is competitive, we will arrive at general equilibrium. That means there will be equilibrium in different markets. So equilibrium in one market causes equilibrium in another market. That's essentially what zero excess demand is supposed to mean. The implication of Walras' theorem on welfare is that agents only care about their own consumption, so they care about maximizing their own utility. And then that agents behave competitively, and that sort of explains how we get to competitive markets. The second conclusion from Walras' work is often referred to as the second welfare theorem. It then states as follows: if all agents have convex preferences, basically the type of indifference curves that I showed, the shape of indifference curves that I showed in this presentation, there are various shapes and there's various meanings behind them. I'm sure Professor has someone presenting on that. But if we hold all the assumptions that we made in this presentation, including convex preferences, then there will always be a set of prices that each Pareto efficient allocation is a market equilibrium for an appropriate assignment of endowments. That does sound a bit sketchy, but let's look into the implication of what that statement then means. It will make sense. So that statement basically implies that prices actually play two roles in the economy. They play an allocative role and a distributive role. Allocative role is to indicate relative scarcity, whereas distributive role is to determine how much of different goods different agents can purchase. And by the second welfare theorem, these roles can be separated. We can redistribute endowments based on wealth and use prices to indicate scarcity. And that is important. That is an important conclusion in terms of welfare. So this makes an efficiency argument, although be it theoretical, that we can redistribute by fixing endowments rather than adjusting prices in the market. And it is actually the second welfare theorem that is used by proponents of basic income instead of other forms of redistribution of welfare in the economy. They tend to use the second welfare theorem to justify why basic income is a much better way of redistribution in the economy. You can read up more about that. I actually found that quite interesting. Um, Thank you so much for listening and watching this video. I hope that I did justice in explaining Pareto optimality and general equilibrium in general. And most importantly, because this is a history of economic thought course that I did link into the economists that were involved in the development of the model as we know it in its modern form. Thank you so much.